Hello, today I've got something to just take apart and I don't have to put it back together again. And it's a Eurodesk made by Behringer. This is the MX8000a and it's an analog desk. It's 24 channels, well 48 channels, because you can kind of flip each channel A and B. So if you recorded everything onto a multi-track tape or something, you can flip to B and have that coming back on that channel whilst you're still recording on other channels. It's all very technical. Something like this looks a bit intimidating because of all the buttons and switches everywhere, but they're not really. As long as you understand what one channel does, the inputs, the equalizer, the auxiliary sends and things, all the way down to the fader here, then every single strip is doing a duplication of each other. Dave on the EV blog recently did a teardown of the Yamaha M3000, I think it was, and that was about 3 times the length of this. I mean, it's a huge machine. He even laid across it like a bed of nails. But the mixer that Dave took apart, each 8 channels was a separate unit that you could unscrew and just pull out those 8 channels and work on it. This, unfortunately, everything is under one sheet of metal. So this has got a couple of little buttons that aren't quite working very well, and 1 or 2 faders are sort of going a little bit stiff. And to be able to actually fix those, it's going to be hours of work taking it all apart just to do a couple of, or rather a few minutes fix, and then assemble it all again. Now, this belonged to a friend of mine who had it in his studio for quite a long time and made lots of use out of it, but now it's being retired and he's moved over to a digital mixing desk, the QU16, which is the same one that I've got, and that's about half the size and actually does a lot more. But Behringer do make the X32, which is a digital mixing desk, and I did have one of those, but again, it was just the physical size that I didn't like. I haven't really got the space, and I haven't got the space for this either, unfortunately. So this is going to be taken apart, and I'm just going to box up as many of the usable components that I can find in here as for future projects or future little repairs and things. This meter bridge here, I was told this was an optional extra and cost, you know, quite a bit of money just for this device. It didn't come with the mixer. You had to order it separately, or order the mixer with the meter bridge and pay extra money for it. So that's going to be interesting. I'd like to try and keep hold of that and make use of it somehow. I haven't got a clue. So just for spare parts here, we've got 16 by 24 potentiometers, so that's 384 potentiometers, plus there's another 21 here, so that's 405 potentiometers, and then these are potentiometers as well, these faders are, and there's another 24 plus 8 plus 1, there's another 33 potentiometers there as well. Lots of buttons, switches. Haven't got a clue how many jack sockets are in the back there, and XLR connectors and bits and pieces like that. But yeah, there's a lot of sort of physical components that I might be able to throw in a bin, and one day I might just need one of these caps and I'll be happy I took it all apart. I'll just show the power supply. The power supply comes with a really long connector, and it's a 7-pin connector, and it's very, very heavy. This is the power supply for it, a 400 watt power supply for the Euro model. There you go. And that's got a fan in the side of it, and it's a little bit noisy when it's running. That's why they put such a long lead on it, so you can get this out of the way and it won't annoy you when you're trying to do your recordings and mix downs. But yeah, there's probably not going to be a lot I can actually use in this, but I'm going to try and scrape together as much as possible. I tend to do that. I've got boxes full of bits and pieces that I might need one day, and I'd rather reuse something than go out and buy it. I mean, why go and buy it if you can reuse something that's already available? So I'll shut up now, and I'm going to try and figure out how to take this thing apart. Okay, let's get some of these connectors off. Every single plug on here has been glued down as well, so that's a good sign. So nothing's going to come loose in the middle of a mix, or some of these desks might be taken backwards and forwards to venues, so they might get knocked around a little bit, and if one of these plugs comes off, you're in trouble, because this has taken me about 1.5 hours to take all those screws off and those potentiometer caps and things, and I still haven't got to the other side of the circuit boards yet. Well, I've decided to just use scissors now to take these things off. Like I say, this is only for scrap parts. So the mixer is all in pieces now. All the boards have been taken out, and I've gotten rid of the metalwork. I've got piles and piles of ribbon cable here, which I'll save a little bit of that. There's lots of hardware, lots of bolts and nuts and screws and things. And well, what have I got? Well, I've got masses and masses of jack plugs. Just tons and tons of jack plugs. I've never seen so many jack plugs on a mixer before. Now, looking down on one of the sections, they are 8 channels on each of these strips, but it's a pity you couldn't just pull them out like on Dave's mixer that he took apart. And where the faders are, even though this mixer looked relatively clean, that tiny gap where the fader is, if you look at the amount of crap that actually makes it through that tiny little gap and down inside the fader, it's no wonder these things start to break down and crackle as they get older. I mean, that's quite a lot of crap in there. Now, on an analog mixer, the audio signal very often runs through the fader, whereas on a digital mixer, the audio signal doesn't run through the fader. The fader is just used as a digital control for the chips and the processors to do all the mixing inside there. But yeah, it's surprising how much of this crap gets down that tiny little gap. Anyway, moving on. What I have noticed in here is there are literally hundreds and hundreds of these single inline package microchips. Every channel has 1, 2, 3, 4, 5, 6, 7. Every channel has 7 of them in there, and they are JRC 4580. They're dual operational amplifier chips. They are. Now, let's move over to this one. This is an interesting board. This, I found it had a couple of different chips here, and they are 2088s. No, 2068, sorry. Now, those are still dual operational amplifiers, but they're more sort of the low noise edition. They're a little bit more quality, probably cost twice the price. But saying that, they're still only about a pound. Anyway, they're very, very cheap. But yeah, there's just masses and masses of them. There's no processors on board or anything for this thing. It's purely all analog. So I will take a few bits and pieces off, and then I'll stash a couple of these boards away, because they're always handy for the potentiometers and things in. There's lots and lots of potentiometers to play about with. As for desoldering these though, I mean, these could be a bit of a nightmare to desolder, because it looks to me like the solder is on both sides of the board. And that kind of makes it a little bit difficult. Even though the through-hole components, it kind of makes it a little bit difficult trying to unsolder these. I mean, I would have to spend days and days to do something like that. So I'd rather just put a few of these away and desolder the one item when I need that one item. However, saying that, I was just thinking, I wonder if you can desolder with one of those paint strippers. This is a bit of a mad idea. I'm just going to... I've never tried desoldering stuff off a board with one of these things. This is 400 degrees Celsius hairdryer, if you like, for stripping paint and things. But I think it takes a moment to warm up. I'm just going to heat the board here and just start pulling off some of the potentiometers. It's probably a crazy idea, it could catch fire, but don't try this at home, blah blah blah, you know, all those usual safety things. I think something's starting to happen here. Ah, yes. Look, they're just pulling off. Easy peasy. Can I desolder this chip in one go as well? Oh, nice. Anyway, let's get some of these pots off. Oh, the components are just pulling off the board quite easily. Anyway, that was just a daft little experiment, but there's a little bit of smoke coming off here, so if you do this, do it in a well-ventilated area. But yeah, the components, once you start heating them up, you can just pull them off, wearing a pair of gloves of course, just start pulling off these potentiometers and things. And I don't really think they're going to be damaged pulling those off like that. But yeah, I guess that's the way to dismantle this. But, I know these things are cheap as chips, but... cheap as chips, never mind. But whether the chip is actually going to be damaged through the temperature. You see, as soon as it starts heating up, I'm pulling it off straight away. So it's not like it's under a lot of heat stress. I'm not heating it from this side, I'm heating it from this side. Yeah, I just wanted to see if that could be done. There you go, look at that. So actually that was a lot easier than I thought it would be, just desoldering bits off with a paint stripper. And I don't think it would have damaged anything. There's lots of potentiometers, and these can always be reused. I mean, they're fine. They're just bog standard potentiometers, and these are the sort of stereo version, the ones with the 6 pins on. And like I say, there's lots and lots of these 4580 dual operational amplifiers. I might seem like a bit of a skinflint saving these bits and pieces, but a lot of my electronics workroom here is things that I've taken off other devices. And now and again, when you come to repair something, it can take you half of the day to go travelling into town in the hope that Maplins might have it in stock, or it can take 2 days to buy a component and have it posted to you. So if you've got one in the box that you've taken off something else, then it really makes life a lot easier. Now, moving on, this looks quite interesting to me. This meter bridge here, well, this LED sort of meter display here, and I'm just going to see if I can fire that up and make it do something. So here's the bar graph display, and it's 10 channels, and it just simply works off 5 volts. There's a couple of pins down here for 5 volt input, and then 10 more inputs for the well, the meters. And this little device here is just sending it a sort of a sine wave so that we can see the lights going up and down. Now, one thing I noticed is it looked at first like there was 24 points on each bar graph, but when you lift it up, there's only 12 LEDs. So one LED is shining through 2 points. So that's kind of an old Amstrad trick. In the early days of buying the Amstrad hi-fis, you would get something that looked like there was a big long row of LEDs when in fact there was only a few behind it, and you had all these little gaps that made it look like it was, I don't know, more professional than it actually was. But anyway, it works, and it works on these simple little BA6820F chips, and they are LED VU meter drivers, and they're 12 points by 2 channels. And there's also on-chip selectable mute and peak hold functions as well, so it'll hold the highest point for a couple of seconds. And yeah, I'll use that sometime in the future. I'm guessing this will all come out and slide off somehow if I'm lucky. Yeah, just take the ends off like that. And this is going to slide out, isn't it? Maybe not. What's stopping it? Ah! Dough face palm moment going off here. There's a little switch poking through here, and that's to select whether you want the tape return or the channel of whatever you're mixing. So, yes. There you go. Simple. So simple that I couldn't figure it out. Now here's a good look inside the meter bridge. Yeah. Lots and lots of stuff in there. But basically what's happening here is this meter bridge is using a stack of LM339s, which are quad comparators. And the way this works is each step, or LED if you like, is biased at increasing voltages, and that is set up by these little resistors here, and they're all different values, and they're sort of arranged in a simple voltage divider circuit. Now there's several circuits on the internet that show you how to make LED meters with 339 comparators, and some of them are much more refined than this, where they use 40 or even 50 LEDs for a more precise scale. So I don't know what I'm going to use this for. I haven't worked out exactly what the pinout is on the cables here, but I don't know. If I could split up the different frequencies going into each of these, the frequency of audio of course, I could possibly make some sort of audio analyzer, spectrum analyzer if you wish, but that will have to be a project for another day. So there you go, a bit of crap from an old mixer, and maybe I can reuse some of the stuff in there. And if you found this useful, please give us a thumbs up, because that does help in the searches, and I'll look out for the next item to take apart. All the best. Thanks very much for watching.